Hey there, everybody. The purpose of this video is to get you some solutions to this Bear Grylls follow-up. I won't read the entire thing to you because I'm assuming you already did. So we were trying to figure out if there's a better model for figuring out how far something's fallen if you know how long it's been fallen. From class, we assumed a 30-foot tall rule garage, a 45-foot tall Grandview drop, a 60-foot tall Letterman drop. Let's see, 4.75, that's going to be 4 times 120 plus 140, wait a minute, 120, 4 times 30 is 120, plus 15 is 135, yeah, 142 and a half foot Thomas Creek, and then 5.5 would be, 5 times 3 is 150 plus 25, 175 feet. So that's what we got in class. Galileo has a model that says you take the time, you square it, multiply it by 16, and that's how high it actually is. So what I'm going to do is I'm going to use Google to do all these. Drag this puppy over here. Okay, so we're going to do, well, the first one's easy enough. The first one I don't need a calculator for. It's just going to be 1 times 1, which is 1, times 16, which is 16 feet. Okay, which is actually a worse approximation than the 30. 16 is about 8 feet shy, and 30 is about 5 or 6 feet too high. Probably do the next one too. I can do this one. 2 squared is 4 times 16 is 64. And again, that's not great. That's not fantastic. 1.5 is going to be a little bit trickier. I wonder if I can do it. Let me test myself. 1 is 1. 0.5 is 0.25, and then 0.75, 0.75. So that's going to be 2.25 times 16 is going to be 36. Let's see how close I got to that. Let's do 16 times 1.5 squared. Not bad, old man. Not bad. All right, back to the document. So it's going to be 36 feet. And again, 36 compared to 42, not terrible. 45 is still closer. 45 is still closer. 64 is closer to 100 than 60 is. They're still both pretty far off. Thomas Creek, 4.75. This is going to push the limits of what I can do in my head. So we're going to come up here. 4.75 squared times 16, 361. Oh, that's much closer. Look at that. 361 is much closer to what it actually was than what the Bears model was. And finally, 5.5. We end up with 484 when it should be 467. That's not bad at all. And remember, there is some error in here because of, our estimation of how long this took. We were being very much, we had a bunch of plus or minus tenths of seconds in there, which can make a big difference, especially when you start squaring them and they start getting up here. So it looks like, we talk about this later. But we do it right here. Which model finds a closer value to the actual height? Circle the correct one. And some of you said, well, it depends, which is a great answer, pretty much always for something that involves measurement. Bears does a pretty good job in the beginning, and then Galileo does a better job at the end. So one way to look at this is if you are on a small cliff trying to do, this all started with Bear trying to figure out how to get off of a cliff and knowing how tall the cliff is. If you're on a small cliff, small being something that you can approximate as under 100 feet, maybe Bear's method is the best. Because Bear, not only is it close, it overestimates a little bit, right? 30 is taller than 24.8. 45 is taller than 42.6, which means if you're trying to get down from something and you're unsure of how much rope or vine or tree or whatever you're going to use to lower, you want to overestimate to be safe. Once you get past 100 feet, even around 100 feet, it looks like Galileo's model does better, but you're not going to be lowering off a 500-foot cliff with a vine anyway. At least you shouldn't be. Okay, so now this is the fun part. This is the fun part. I'm going to have to add a page down here. I want you to figure out what the units on this 16 are. Okay, so this is what we did in class, and I think it worked pretty well. I'm going to start a new page down here. I'm going to insert. This is going to take a couple seconds. Hang on one second. I'm going to insert some fractions. So we have, over here, we have feet that we want to come out. And we decided that feet over 1 is totally legit. We like the idea of when we need to have feet to come out, that's the same thing as feet over 1. Okay, now, we've got this 16 that's going to have a fraction, which I am now going to erase the numerator and denominator of and put question marks over question mark, and a question mark. Okay, beautiful. Okay, those are the units we're looking for right there. We are multiplying that by a time that is squared. So if you think about that, I'm going to put another fraction here. I'm going to change it. Put a multiplication sign between them two. I'm going to change these fractions now. Toggle fill codes. Okay. So we know we're taking seconds, and seconds is over 1. And we are squaring that. It's a little ghetto, but I think you get the point. Now, if you're squaring seconds, you're going to get squared seconds. So what I'm going to do is I'm going to rewrite this. New comment. Oh, not new comment. That's not what I want to do. I'm going to toggle this. I'm going to toggle this. I'm going to toggle this. Okay. Why aren't you looking to toggle it? Maybe if I do it this way. Okay. We're going to delete the whole thing. I don't know what's going on. Here. We're going to write it as seconds squared over 1. Okay? Because that is what actually is going on. You're taking seconds and squaring it, then when you get squared seconds. Now the question is, we need to, whatever is here, multiply by this and get rid of those squared seconds. So what we discovered in class after the past week or so of work is in order to get rid of a unit in a numerator, you have to match that unit in the denominator, which means this puppy down here has to also be seconds. Whoops, let's spell it correctly while we're here. Seconds squared. Because that will allow us to divide that seconds off with that seconds. You can actually indicate that if you want to. Toggle the fill codes. Strike out. There we go. This one, if you want, we can just toggle the fill codes here too and strike this one out. Now, it's not quite as nice as in class with a red marker, but you know, it gets the job done. So we know the denominator has to be seconds squared. Well, what does the numerator have to be? Well, we're done calculating. The only thing we have to do is figure out what unit we want, and we want feet out here, which means we don't want feet in the denominator because that would delete off the feet. So that means the feet have to be in the numerator. So the unit you're looking for on your 16 is feet per seconds squared, which is one of the more confusing units from physics if you've ever taken a physics class or if you are planning on taking a physics class for your general studies requirements. It's an acceleration unit. Speed, Bear's 30 was feet per second. Feet per second. Okay? So feet per second is perfect because that tells you how many feet you go each second. What we're talking about is not something that is changing its position the same. For example, in his, every 30 feet you picked up, every second you picked up 30 more feet. With Galileo's model, every second that passes you actually pick up more distance than you did the time before because it's accelerating. And that's why these seconds are squared down here. Feet per second, or feet per second squared. All right, I hope that helped. We'll catch you in class.